Hello everyone, I am Saida Sanafar and Fatima Shiha. We are excited to present our math modeling project, which fosters creativity and interactive learning through 3D models. First, we are going to see about lift system. As we can see from this model, the lift system is critically component of any building, requiring careful consideration of the mathematical concepts to ensure an efficient operation. Force and torque. To determine the force required to lift a load, we use the formula F equal to m into g, where F is the force, m is the mass of the load, and g is the acceleration due to gravity. For instance, suppose we need to lift a load of 100,000 kilograms. Using the formula, we can calculate the force required. F equal to 1000 kg into 9.81. Mass R x square equal to 9810 N. Where torque required to rotate the lift pulley system can be calculated using the formula tau equal to R into F, where tau is the torque, R is the radius of the pulley, and F is a force. And now we are going to explore how mathematical informs the design of this building. As we can see, the building structural integrity relies on the careful calculation of stress and loads. To determine the axial stress on a column, we use the formula sigma equal to F divided A, where sigma is the axial stress, F is the axial force, and A is the cross-sectional area of the column. For instance, suppose we have a column with a cross-sectional area of 0.1 square meters subject to an axial force of newtons. Using the formula, we can calculate the axial stress. Similarly, we determine the bending stress on a beam. We use the formula sigma equal to m divided I divided y. Sigma is a bending stress, m is a bending moment, I is a bending inertia, y is the distance from neutral axis. For example, suppose we have a beam with a moment of inertia of 0.01 cubic meters subject to a bending moment of 10,000 Newton meters. Using the formula, we can calculate the bending stress sigma equal to 10,000 Nm divided 0.01 m cube divided 0.5 m equal to 2 lakhs PA. And next, we are going to see Max model of lighthouse. As we can see, lighthouse is a towering structure that requires careful consideration of the mathematical concept to ensure its stability and effectiveness. In this presentation, we explore the mathematical principle behind the lighthouse design and operation. Structural integrity. The height of the lighthouse can be calculated using the formula h equal to root of 3 into E into I divided P into G, where h is the height, E is the model of elasticity, I is the moment of inertia, where P is the density of the material, and G is the acceleration due to gravity. For instance, suppose we want to calculate the height of the lighthouse given a modulus of elasticity of 200 GPa of a moment of inertia of 0.m4, a density of 2500 kg into m cube, and the acceleration due to gravity of 9.81 m into s into square. Optics and lightning. The intensity of the light emitted by the lighthouse can be calculated using the formula I equal to P divided 4 into pi into d square, where I is the intensity, P is the power of light source, and pi is a mathematical constant approximately equal to 3.14, and d is the distance from the light source.
Next is the presentation a 3D model of crimes and investigation, which showcases the application of engineering mathematics in solving complex problems. As we can see, the model includes various elements such as security cameras, eyewitness locations, fingerprints, DNA samples, footprints, bullet casing, and blood stain.
And finally, we are going to see mathematical concept in Ferris wheel. As we can see, the Ferris wheel is a maximum stress with a diameter of 50 meters and height of 30 meters. To understand the mathematical principle behind the impressive structure, let's dive into some calculation. Circumference and angular velocity. To calculate the circumference of the wheel, we use the formula C equal to 2 into pi r, where C is the circumference, pi is the mathematical constant approximately equal to 3.14, and r is the radius of the wheel. For instance, suppose we want to calculate the circumference of the Ferris wheel using the formula. We can calculate C equal to 2 into 3.14 into 25 meter equal to 157 meter. In conclusion, the presentation showcased the application of mathematical concepts and engineering mathematical principles. Thank you.